Thank you, Andrew. So hello, Riga. I think it's my 10th time here. I mean, not at DevTernity, but in Riga overall. I used to work here, and actually that makes me so scary because some of you might have seen my code. So be gentle on that, please, okay? There's no need to bring it back. We can talk afterwards. My name is Jakub Pilimon, and currently I work as a software consultant. My current employee is Vattenfall IT Services in Poland. When I do not code, I run classes as a trainer in a company called Bottega IT Minds. And here's my Twitter handle, if you want, drop me a line. Here's my blog. My main area of interest are object orientation, domain-driven design, test-driven development, and architecture. Okay, so welcome to this presentation entitled Refactoring to Event Sourcing, No Slide, Just Code. There are at least 2 lies in that presentation title. There's going to be more than event sourcing. We're going to focus on events, but we'll cover event sourcing and refactoring to event sourcing. And there will be like 3 or 4 slides. I'm sorry, okay? They will jump in between the coding session, okay? So, all right, let's get it started. First of all, why do we use, as developers, why do we use events in our code bases? And I think I have several reasons for using events in my code bases. First of all, is inversion of control, like good old Swing applications used to do. So observer pattern, right? We won't be covering that today. Second of all is to have event sourcing, so a different idea of retrieving state from our database or something like this. And I think we as a community of developers are already past the time of explaining what event sourcing is about. Is there anyone who doesn't know what event sourcing is? Hands up. The definition will come up later on in the code, okay? So I will stick without the definition right now. It will be brought up during the coding session. Third idea is to have event-driven architecture, of course. So loosely coupled, for instance, microservices that talk with each other, for instance, via messaging infrastructure, right? So the consumer doesn't know who the producer is, the producer doesn't know who the consumers are, so it works vice versa. So we're going to cover event sourcing and event-driven architecture, and here is the agenda of the live coding. So we're going to start with modeling a normal DDD-like aggregate, so object orientation, to be honest, and then we'll just turn it up with events. So after 10 minutes, you won't see any events, so do not be worried, I didn't mistake the title of the presentation. We have to start with normal aggregate without events, because we have to refactor to event sourcing, okay? And then we'll go with event-driven architecture with the use of Spring Cloud Stream. Who amongst you have ever heard about Spring Cloud Stream? Hands up. There are a couple of people, cool. So we'll use that at the very end of our session. We'll build a fairly complex event-driven architecture, okay? Okay, so let's get it started. Not this slide, but the code. So I have chosen credit card as an example of our aggregate. This is just a showcase, okay? It's a demo. Do not use it in production, because otherwise, I don't know, the world's economy will collapse or something like that. It's just a showcase. And all of the code that we'll write today, it will be available at my GitHub account, and the link will be on the last slide, okay? So let's get it started. First of all, what we should do when we try to model an aggregate, we should try to find and focus on the behavior that our aggregate is exposing to us. To find those behaviors, I recommend you such techniques like event storming or domain storytelling, but we don't have time right now to cover that. So let's assume we discovered such a behaviors, like we can assign a limit to a card, we can withdraw from a card. That makes sense, right? We can repay the card, so we can do the repayment. We can close the billing cycle, and we can ask the credit card, hey, what's your current available limit? Okay? So this is the first stuff. Find the behaviors, and then we should try to focus on what are the invariants that protects our objects from going into inconsistent state. So basically, these are the if statements that are protecting our behaviors. And I personally like to have them written down as the test cases. By the way, is the font size big enough for the guys in the back? It's cool? Okay. For me, it's too small even from here. That's why I have this laptop. Okay, so the second step, invariants written down as the test cases. right? So for example, we cannot assign the limit to a card when the card already has a limit. These are invariants. And we don't have time for proper TDD, so I will just code every test up front, and then we'll focus on implementation, okay? So this is basically, the first test says, hey, I can assign limit to a card. This is freaking simple. When someone tries to assign limit to a card, let's say $100, then the card's available limit should be equals to 100. This is very, very, very simple, like getters and setters. Second one is more complex. Cannot assign limit for the second time. That means that when someone already assign a limit to a card, and when someone else is trying to reassign the limit, let's say for the 50, then basically we should react, hey, you cannot do that, you are breaking the invariant. So for example, illegal state exception can be thrown, right? Cannot withdraw amount when we don't have money, when it's not in limit. That makes sense. We cannot use money that we don't own. So given a card that has a limit of 100, let's say, when we are trying to withdraw more than 100, let's say 101, then again, something should have happened, like illegal state exception should be thrown. Makes sense. Cannot withdraw after 45th withdrawal in the cycle. That means that we are allowed only to use the card 45 times, regardless of the money during the one billing cycle. So this is more complex. Given a card with assigned limit 100 or 1000, when or and someone used the card 45 times, so we can write it like this, 45 times, we use the card, let's say $1 each time, so we are still in the limit. Then when someone comes and says, okay, I can withdraw one more, then we should be throwing illegal state exception because it's 46th trial, right? So we cannot do that. Can withdraw from a card is simple. We should just check whether the limit is lowered. So we have a card with the limit 100. Then someone comes and says, okay, I want 50. Then available limit of the card should be equals to 50. That makes sense. Assign limit to 100, we are withdrawing 50, so there is 50 left. Can withdraw a limit from a card? Can withdraw from a card in the next cycle? That means that even though I have 45 withdrawals, when there's next cycle, I can still withdrawing. So given 100, 45 withdrawals, and one more withdrawal, or no withdrawal, but the cycle is being closed, then we are able to withdraw again. This is the invariant, right? So when someone is withdrawing one, we shouldn't be throwing illegal state exception, but we should be saying that available limit is 45, 46, 56, right? No, 56, 54, I guess. 100 minus 46, it's 54, makes sense. And the last one, can repay a card. It's rather simple. So we can have a card with a limit 100, not available limit, but assigned limit 100. When someone tries to repay or withdraw first 10, and he is repaying immediately this 10, then available limit of the card should be equals to 100 again. Okay, so we have the test. They won't be passing because we don't have anything here, so let's just focus on the implementation, and then we go with events. So I can assign limit only then a limit was not already assigned. If the limit was already assigned, so if limit already assigned, not here, but here, assigned, then basically we should be throwing new illegal state exception, right? And if not, now is the time to think about the data structures. So first behaviors, then invariants, then data structures at the least important stuff. It let us coming with the minimalistic design of our aggregates, okay? So let's say we are keeping the limit in, I don't know, big decimal. So this limit equals amount. Now it's time to make it compile, create field, and that method should also go here. Limit was already assigned. Is the question whether limit is not equals to null. That makes sense. The same we should do with the withdrawing. I can copy-paste that to make it quicker. It will just be changing the invariant name. Not that, but this one. So when we are withdrawing, we have to check two invariants. First of it is amount in limit. We have to pass amount here. Second of that is if too many withdrawals in the cycle, then we are throwing some exceptions. I missed that here. And if it's done, then OK, again, thinking about the data structures, we should be keeping track of how much we have already used, probably, again, with some big decimal. So let's create this big decimal. Should be 0 at the very beginning, right? Create field, not object, but big decimal used. And this is equals to 0, right? Cool. Now we can implement that method, is amount in limit. That means we have a available limit, current available limit, is amount not in limit, it should be right here. Because we are throwing exception, so it doesn't make sense. Is amount not in limit. Available limit comparing to amount that we want to withdraw is lower than 0, so we don't have enough money, we are throwing an exception. And this invariant should say that, OK, return current counter of withdrawals in the billing cycle. So I guess integer would be OK. Withdrawals in cycle bigger or equals to 45. I guess bigger or equals to 45. We don't have that field, so we'll create that right now. Create field. Cool. Just great. Why? No, because when you have 45, you cannot repay, or you cannot withdraw more because you already used 45, right? Oh yeah, you're right. Thanks. Sure. Yeah. Good. Thank you. I don't have any gifts to spare. I can give you water. We have a lot of water here. OK. Thank you. Repaying the card means the used amount should be lowered to amount, because we are not just repaying, and closing the cycle means withdrawals in cycle equals to 0. Cool. Available limit means not 0, but this is basically limit. Subtract what I have already used, right? So this one. OK, I think we are done, and we can check whether the tests are passing or not. They are not passing. One of them is not passing. Cannot withdraw after 45 withdrawal. Here, now it will be passing, right? The edge condition that you mentioned. But it would be working with my code as well. Why it's not working here? Yeah, sure. That's good. Good to know. We should be increasing the counter, right? Data structures are not that important, but still they are important at the very end to make our test passing. Cool, thanks. And now should be 45, right? I hate age conditions, to be honest. I always failing at them. That's why we have to have tests. It's not passing. Why it's not passing, by the way? Now 44, because you changed the condition. OK, so now it will be passing. No, it's not passing. You know what? I will leave that test, and we'll come back to that later, OK? It should be 46, should be 45 here. 45, but the edge condition should be bigger or equals, right? Because when we have 45, then basically we cannot withdraw more. Right? Yeah, that makes sense. So I'm not giving you water. It makes sense. Yeah, I cannot withdraw more if I have 45. OK, luckily we are done. So this is the first part. So modeling the aggregate, hopefully we managed to do that with the last test. So now would be the time to think about events. So think about when and why to find events in our code, and how to do that in refactor to event sourcing, OK? So we are done with the first part of the demo. And what we should do next, we should try to find the events. But if we take a look at the modeled code, all of the behaviors have the following pattern. So we have the behavior exposed as a command. We can run a command against our model, right? We can throw a command against our model. Then we can check in the invariant. If it's passing, then OK. If not, this is invariant. If not, we are saying to the client, I'm sorry, and I'm not acknowledging that. I understand your command, but I cannot pass it through. So go away. Illegal state exception, right? But from this moment on, this is basically ACK, right? So I'm acknowledging this command, and this is the place where I cannot deny my command becoming a fact. It's happened. It happened, so I'm translating the command to a series of domain events. This is that place. It can be one event or more of them. But still, how to find them? We should extract the method which is being responsible for state transition. So the state transitions are the places where you should look for your events. How to find the name of that event is basically, we should try to name that method that I'm going to extract and add past tense to that method. So it should be assign limit, and past tense is limit assigned. And we are just finding the first event, limit assigned. This is the name. How about what does the event carry in its content? So what are the properties of our event? This is very easy, because first of all, it always should have the ID of the throwing object, so credit card in that case. It should have a timestamp when it happened, and everything that our IDE extracted to that method should be also in the content of that event. In that case, it's just an amount plus timestamp plus ID. And what we should do, we should try to fix this method when it has like several parameters. We change it and wrap it in one method parameter and call it, for example, limit assigned. And now, what we should do, and limit assigned is a prepared class which has all of that content that we have talked about. So timestamp, ID, and limit. Now we make it compile. So here we are throwing new limit assigned, ID, and new limit, which is amount, basically. And we are saying here that, OK, we are not taking amount, but limit assigned, get limit. The same exercise we should repeat in all our places when we are talking about data structures. So card withdrawn here. And again, this is not big decimal amount, but card withdrawn. Card withdrawn. And we are making it compiling, basically. New card withdrawn, ID, and I guess amount. And here it doesn't compile, so we're taking the amount from the event, so from the parameter. And the last two ones are not protected by any invariant, by the way, so we are just taking the whole method and saying cycle, not cycle, but card repaid. And we are changing this to card repaid. Yeah, all of them, I was going to say that afterwards. All of them has timestamp when you are constructing them here, okay? And all of them are backed by a common interface called domain events, which has an aggregate ID, so the object ID, and the timestamp as an exposed behavior, okay? Just to make it simpler, it's created in the field. Okay, let's go back to the example. So repaid, new card repaid, amount, not amount, but ID, amount. And here we are taking the amount from there. And cycle closed, so the easiest one is just cycle closed. And the content of that event is just ID of the card. Yeah, we shouldn't be breaking any tests, by the way. I think they will be working afterwards. We'll check that. So, but now we are just throwing an event, the events up to the air, right? We are creating a new instances of events, but they will be like garbage collected in no time. There's no one collecting those events. So we could make our credit card responsible for gathering all of the events that the credit card emitted. It's the one who emitted the event, so maybe it should be also responsible for gathering the events. And then when someone's trying to save the card, like persist in a persistent storage, then this guy could ask, hey, your credit card, what are your pending changes that I need to flash? This is basically the same scenario when we have like normal ORM-based systems and we are calling save, or dirty checking mechanism is calling save. It checks what are the pending changes to be flashed to the database, right? It's the same scenario. So we could copy-paste that scenario from ORM-based system dirty checking and implement that here. So let's make our credit card responsible for gathering all of the events that it gathered during one transaction. To do so, we need private final list of domain events here. Let's call it pending events. It should be a new array list, let's say. Cool. And every time we are throwing an event, we should add it to internal collection. So here, pending events add limit assigned. Also, when we are withdrawing, so here, we should add card withdrawn. And two last ones, so here, we should add card repaid. And when we are coding the cycle as well. We are missing still a behavior that would answer us the question, what are your pending events, dear credit card? So let's create that. I'm going to create a getter for our pending events. Excuse me? In a few minutes, we'll write a repository for that. I can then answer the question, OK? So we are just we have the pending events. We need the getter for that. I'll just make getter like this. Cool. And now we are going to write the persistent storage, so repository, OK? Repository, its responsibility, as we all know, is to save and to retrieve state from the database. So let's create the repo. It's going to be here. Let's name it repo. And it has following behavior. So it has public void safeguard, credit card. And it has public credit card load by, of course, ID. So two simple behaviors. Let's return null for a while. And let's try the test for that so that we can be sure it's working. Repository test. And let's create a repo here. Equals new repo. Should be able to save and load card. Very simple scenario. So given some ID, random ID, let's say, when we are creating a card, so credit card, new credit card ID, and when or and someone is assigning a limit, let's say, and saving the card to a repo, and then loading again to the different object by ID, then basically the loaded object should have limit as previously assigned, right? Loaded available limit equals 100. OK, this test will fail, of course, because we are missing the implementation of the repo. And now would be the time to think how we are storing the changes. And if we think about it, we have like each card has its own events, right? So each card identified by a unique identifier by the means of UID has its own stream of events, right? So I can write here what I have just said, that each card has ID, and it's mapped to list of domain events. These are in sequence, right? Not this. Import, and let's call it event streams. Equals new concurrent hash map. And we have like our persistent storage, which is basically in memory right now. Each card has a stream of events. Saving means adding pending events to the end of the current stream of events, because we are not storing the state, but we are storing immutable chunks of changes. That's it. So to save a card, we need to have current stream of events, which is basically like this. Current stream equals event streams get or default credit card get ID, or if it's empty, so null, give me a new array list, so I don't have null pointer exception, right? To the current stream, at the very end, we are adding new events. New events are gathered in credit card, right? So current stream add all, credit card get new events, so get pending events. I want it as a separate variable to be more clear, like this. And then we are saving the new stream to our database in case in memory, right? Current stream. And we have to say, okay, dear credit card, you are now flashed. You are now not dirty anymore, like comparing to the language of ORM, dirty checking. You are just now clean object. So dear credit card, it happened, events flashed. Pending events flash. Clear, I think is the name. So when it fails, that's the answer to the question. The transactions rollback, you don't say anything. So either we are saving all of the events or nothing. It's basically the same with ORM. Either we are saving all of the fields that have been changed, or we are saving nothing. Of course, in the production-ready environment, it should be backed not by a hash map, by some kind of event store, which is basically out there for you to get, like geteventstore.com by Greg Young and his crew, and other stuff like this. You can use Kafka, for example. Okay, that saving is easy. Saving is really easy. The complex stuff comes around when we are talking about retrieving state. And this is exactly what event sourcing is about. So if we take a look at this slide, it's about user, but the concept is the same. I've just stole that from my previous presentation. We have stream of immutable events, chunks, and we are having initial state, which is basically an empty object, and to that against that empty object, we are handling the first event. The resulting parameter is mutated state of credit card. With that mutated state, we go to another event in the sequence, so the second one, and again, we are repeating the exercise up till the very end. Is there anyone who likes functional programming here? This is basically left fold. This is left fold on the stream of events. We are aggregating to a result called credit card in that case. Left fold. So let's try to implement that. It's going to be more complex, so I'm suggesting a factory method, static method on credit card, recreate from ID and current stream of events. ID, if it's null, then array list. It doesn't compile because it's not there. Makes sense. Not here, not here, but here. Cool. Let's return null for a while. I'll just rename it because it's not all default, but it's events. And now Java 8 doesn't have like out-of-the-box support for left fold. We could play with reduce. It's nothing like it's not the same. Or we could play with for loop or weird while loop. Or I can cheat and use a library called Java Slang and have left fold one-liner. And I'm going with the last one, okay? Because I'm lazy. So it would be Java Slang. There's a typo. Collection, list of all events. Fold left, or left fold, I always forgetting. Fold left. Initial state is the first parameter. Our initial state is just a new credit card with ID. And here I'm using a hint for the ID. It says that I need a lambda parameter, which takes a credit card event and returns something more. This is basically the way how I'm treating specific event to my mutated state. So I'm calling that handle, for example. Handle event. Of course, we don't have this, this method yet, but I will create that soon. Create method handle. This is a function. Function which takes as a parameter credit card and an event and returns credit card, mutated. Okay, now we can just simplify that to make it one-liner. Here, static import, and it looks much better right now. I think we're missing something here. Here. Cool. So we have the handle method, and here, again, it's either 4 or 5 if statements with instance of, or we can go more with functional programming and stick to functional programming and notice that it is just pattern matching, right? This pattern match event to a specific handler. Again, no pattern match. At least I don't know how to do pattern matching in Java 8, so I'm stealing that from Java slang. Just Java slang, API match. We are matching event of several cases. Case 1, hey, dear event, are you limit assigned? If you are limit assigned, then please go to that specific handler. And which handler? This is the handler we created at the very beginning. The method we've been extracting. These are the method that mutate our state, right? So I'm saying this is limit assigned. Import static, and it's not combining. Because limit assigned is terminating the stream. As you see, it's not returning anything. It's mutating, but it doesn't give back anything for the rest of the stream. So we have to mutate ourselves and return mutated state, like this. And to be honest, we can repeat that exercise in every handler, like here as well. And with two last as well. So card repaid, we should return this. And with cycle closed again, we should return this. Cool. And now we can do what I like the most, so copy pasting. 1, 2, 3. And we don't comma here. Yep. Now we have to correct the events, of course. This is card withdrawn. If it's card withdrawn, then go here. If it's card repaid, then go here. If it's the last one was cycle closed, then go to here. This is basically left fold with the function that is pattern matching our next event. Event sourcing is all about pattern matching and fold left, nothing more. So now we can go and try. What I like about Java slang is when it compiles, it has a good chance of working, actually. So let's try it out. Maybe it's working. Fingers crossed this time, no problems. Yeah, it's green. So we happily implemented event sourcing with pure Java, okay, and with Java slang. But we could do that with pure Java. Trust me, but it looks terrible. So the idea of event sourcing, just to sum it up, is like this: that we are consuming stream of events. These are immutable. What is the advantage? Advantage is that we have natural audit log for our object, right? So we see what happened during the life cycle of our object. Plus, this is an audit log that we can really prove, because this is audit log that we are recreating state from. So it cannot be like not truth. We can go and cut the stream in half and see what was the state like 2 days ago when we had a bunch of exception logs in logs. So we could create the state on our local machine from the yesterday, for example, and run specific command and debug. Of course, it doesn't work when you have like lot of aggregates. It works only with one. There are, of course, some disadvantages. There are. Like, you have to think about versioning the events. What happens when I have an event, it's already on production, I have to version that, or I made a mistake, I cannot delete that, I cannot run SQL scripts like we all do today. We have to think about compensating events, so the events that will roll back the effect of the wrong event. And it's bigger learning curve also. So it has drawbacks, but it has advantages. In my opinion, the biggest advantage, and people do not talk about that, is that it forces every developer that goes to our code base to think about business events, because they are in the code. So like he cannot miss that. It's there. It forces us to think about the business. When we are implementing some domain and solving the problems with our code, we have to think about domain events that are happening in the real time. And if we can make them our slaves and put them in our code and lock them there, or just more humanish, like first-class citizens of our code base, then it's easier to reason about the domain, because the domain itself, it's just series of business facts, and then we have it in the code. Okay, so this is about event sourcing. The beauty of that is that we can now have our event log, and we could throw it out to someone else. Like, I'm the producer of event log. This is my event log as a credit card, and I can give my event log to someone else. so that he or she or another microservice, for example, can take a look at this and have different perspective on my event log, right? In our case, we have withdrawals, repayment, billing close was closed, billing cycle was closed, and so on and so forth. We could send this event log to some risk management system to detect anomalies, to do, I don't know, some specific algorithm prediction, and so on and so forth. We could do whatever we want. The beauty of that is that everyone else can have different projection of the on our event log. And let's actually create such a scenario. We could go with a simple one like this. We have a producer, we have a message broker in the between, and the one consumer. Or we can go with more complex, like this. Let's say we have a credit card, and every time the credit card is, someone is withdrawing from the credit card, risk management system has to check whether it's fraud. If it's okay, then he's throwing in another event. The communication context is taking that event and checking whether everything is okay, sending an email, and so on and so forth. Basically, we could create such a business process based on events, and the starting point is up there, and each of the components are throwing different events. But then we would have a problem. I've seen code bases like this, and basically it's not possible to follow what is the business process of withdrawing, because it's spread out on the different bounded contexts. It's hard to follow, it's hard to maintain. What if we had like multi-tenant application, and different clients should have like different process of withdrawing? Then in the worst case, we have to redeploy 4 units. It sucks, right? So it's better to have one guy in the middle who is orchestrating the whole process. In enterprise integration patterns, this guy is called process manager, and this one gets the first event and orchestrates the rest of the process. Now we have like one person responsible for the process, orchestration, for business logic of that process, one thing to follow, one thing to redeploy when we want to change it. Let's actually go with the second scenario and try to implement that on top of Spring Cloud Stream. So what we're going to do right now is we're going to take our application, that one, and we're going to send our events to a message broker. And then the other guy, this process manager, will connect to that message broker and will be looking for card withdrawn event. When it's there, he will throw events or commands to messages, basically, to risk and to communication. Just this basic scenario. Okay? So to do that, I will use Spring Cloud Stream, which is basically a tool that allows us to connect microservices, Spring Boot based, that would like to talk with each other via messaging infrastructure. And the beauty of that is that it operates on abstraction of channels. Let's see how to create a channel. So channel is communication path via message broker. So I'm creating a new class here. It's called channels. It has to be an interface, by the way. It's that simple. And our producer, so credit card application, is just a producer to one channel. So we are putting here one channel named, it's an output channel, of course, named cards. And it's message channel named cards. So this is the definition of the channels that our application will be talking to. It is a source to one output channel, basically. This is the first step we need to do. The second one is we have to go to our application and say, OK, please enable binding to specific channels. Which channels? Those specified by this class. This is the second step. The third step is to take a look at our class path and see whether we put some specific binder. I personally chose Kafka, and now Spring Cloud Stream will try to talk with Kafka. If I put here a RabbitMQ binder on the class path, it will try to talk via RabbitMQ. That's cool because channel is an abstraction and specific implementation is based on what I have on the class path, like everything in Spring nowadays, right? So I'm choosing Kafka, which is basically, I'm going to double check that, running in the background on my machine, it's running. And the last thing we have to do is we have to basically say to the configuration file that we are talking with one channel, its name is cards, and topic will be named cards topic. And in that way, we'll have card topic on Kafka, and I think we're good to go to start the application. but we have to simulate that someone is already using that. So to simulate card usage, I will have, let's say, scheduler, for instance. I will enable scheduling here. I will insert here private final repo. And every time someone is saving something to our repository, I will make it Spring component. Not only we will store it in event stream here, but we will also throw it away to our channel, just newly created channel, so topic in Kafka, okay? So that others can listen to that. So here I need to inject our channel definition, which I named channels, I guess, channels, yes. I'm injecting channels here. And for every new event, so and every pending event, I can say, hey, pending events for each of you, event, channels, cards, send new event. Its payload is basically event. And now we are just, every time someone is saving a card, new flashed event will be also sent to Kafka. And the last thing we have to do, we have to simulate like every 2 seconds someone's using a card. So let's do so. Scheduled fixed rate 2 seconds, public void random cards, or something like this. And let's say we have a card equals new credit card ID, random ID, credit card assign limit 100. It's not groovy anymore, so I have to do new big decimal, not that one. New big decimal, not that method. Now it should be it compiles. Let's say we are withdrawing something. Withdraw 10. I'm lazy because 10 is already in the big decimal. Credit card repay 10, hopefully. And then we are closing the cycle, and we are saving the card. And at this moment, we are creating 4 events that should be flashed to our database, so hash map, and to the Kafka topic, right? We are saving the credit card. Cool. And now we can start our application, and I hope we won't be seeing any exceptions. That would be a good sign of that everything is working. But we'll double check that on the other side, on the consumer side. And I have only 8 gigs of RAM, so it takes time to start it. Excuse me. Oh, it started. So it started with no exceptions. Let's go to the second application, so second Spring Boot backed application, and try to get those events and build this process to risk management system and to communication, okay? Okay, so let's go to the second one. It's basically the same. We have a Spring Boot application. I will create also a specification of channels, but this guy, this process manager, will talk with 3 channels, basically. One of them is input channel for cards, the one we specified basically on the other side just. This is subscribable channel, named cards. And 2 of them are output channel. It's risk. And the other one is basically communication. I'm lazy, so I copy-paste that. And I think there's a cool shortcut for that, like this. Communication. Should be fine. 2 output channels, 1 input channels. Our process manager listens for cards and throws to risk and to communication. So specification of channels, we have to enable binding in our application. Not scheduling, but binding to that channels. We should also check the properties. It's already there. I forgot to cut them. So cards, risk, communication, and 3 topics over there. It's cool. And whether we have a proper binder on the class path, it's Kafka, so it has a good chance of working. We need 1 method which will be invoked every time there is something on our channel that we subscribe to, so cards. So it's named stream listener to a name of the channel, which is cards, public void handle domain event, right? We are throwing domain events on the other side, so we are gathering domain events on this side as well. For a while, let's just, I have 5 minutes. Okay, challenge accepted. Event to string. Let's try to run it and see whether it works. It should be getting some events, right? Every 2 seconds, it should be getting 4 events. It's starting. It's connected to Kafka, yeah, and we are getting events. You see here. I don't know if you can see that. I cannot, but I can see that here. And yeah, now we are left with one final act, this process manager. So we are getting card withdrawn, we have to contact risk, and we have to contact communication. To do so, I will start with a test. I have already prepared skeleton. It's an integration test, end-to-end test. We have to simulate via Spring Cloud Stream testing tools that something arrived on our cards channel and something was thrown on our output channels, right? And it's very easy. We can basically say that given there is a withdrawal, we have to communicate risk and communication. So when on our input channel there was a card withdrawn event, how we can simulate that? We can, for instance, insert here our channels, definition of our channels, and say when on channels cards someone sends a message. What is the message? The message is new card withdrawn. Some random ID, and let's say 10. That's it, and this is the input scenario. What about the output? We have to somehow intercept what is going out from our application, to the risk and to communication. So to do that, it comes with, Spring Cloud Stream comes with a message collector, not channel, but message collect, something like this, yeah, message collector. And it has an ability to gather all of the messages that are being thrown outside and collect them in a blocking queue. One for each channel. The second one will be communication. Let's initialize them here. So risk blocking queue is message collector for channel. Which channel? I'm taking that from our definition of channels, so here, and communication as well. Message collector for channels communication. Cool. And now we can say that, okay, every time there is something on the input, we have to have two messages on the outputs. So I'm pulling my my blocking queue, and I will just cast it to string. Sorry for that. And I will check that it contains a message. Let's say check fraud. Right? Cool. It should be okay. And the same with the second one. Not risk, but communication poll as string. This one should contain send mail. Let's run this test. It will fail, hopefully, because we didn't implement that logic. It should have, for example, I guess null pointer exception here. I don't know. Let's see. It's failing. And now we are, as a final act, we try to make this make this test green. So I'm saying that if our event is instance of card withdrawn, then basically we are sending two messages. How we do that? The same as the previous example. We are rejecting channels here. Channels, and yep. And we are sending channels here to the risk. We are sending new message, send new generic message. It was check fraud, I guess. And the second one was channels communication, send new generic message. And the payload is send mail. Was it like this? I don't remember. I have to double check. Send mail, check fraud. Send mail, check fraud. Now let's rerun this test. And if it's green, that was the final act. Did I manage in 5 minutes or not? Cool. I don't know yet if it's green or not. It's green, yep. So that was it. The conclusion would be event sourcing with Java. It's really easy, but you have to use like production-ready storage. I recommend getEventStore.com. Event-driven architecture with Spring Cloud Stream, really, really easy. We are operating on the abstraction of channels, and we can have problems when we do like events waterfall instead of process managers. I'm happy to take QAs. That's it. Thank you all for coming here. I see you on the beers, I guess, tonight.
Yeah, thank you. Yeah, maybe two questions because we're kind of out of time. So, what about 2-year event long for 1 million objects? Starting an application would take a lot of time to get the state.
Yeah. That's a very good question. You have to use snapshotting. Basically, if you are familiar with, for example, how database works underneath, it works the same way. You have an event transaction log, and each time, like, I don't know, every 100 events in our case, we have to have a snapshot of our credit card. So that when we are loading state, we are not loading like 1 million of them. We are loading the last snapshot and the events that happened after last snapshot. It's a fairly known pattern called snapshotting. For example, getEventStore.com, so EventStore by Greg Young, it supports that out of the box. If you are familiar, for example, how ACA persistence works, so actors, there is also the same mechanism underneath of persisting in actor state. That would be the answer.
Yeah, okay. The next question is, if you have a business event that spans multiple objects, or for example, a card event that spans several accounts, 2 accounts at least.
You mean like, I don't know who's the, the owner of that question, so I don't know who I'm talking to. I mean, events belong to one aggregate. If our events should span across different aggregates in one transaction, from the rules of DDD, maybe we have mistaken the border of our aggregate. Maybe we are missing a bigger aggregate, like transaction, which spans 2 accounts, right? That would be the answer. So I would think about the size of my aggregate, whether it's correctly created. But I'm happy to talk about this scenario with the owner of that question afterwards.
Okay. Maybe last question. You used pattern matching in your code. Is there any more elegant way to do that?
That wasn't elegant? I don't know, to be honest. In Java, no, I don't know. In different languages, yeah, it's super simple. For example, in Scala, it's super simple. I don't know any better way in Java. You can go with instance of ifs and so on. Maybe there is some better way to do it. I always use pattern matching from Java slang.
Okay. Yeah. Thank you. It was the last question.